So far we've looked at taking the first derivative of a function. By definition, if the derivative is differentiable, then we can also find the second derivative. Second derivatives are then defined to be, if you notice, double prime, the derivative with respect to your x of the first derivative. So, on that notation, we know that we can find a second derivative, a third derivative, a fourth derivative, etc., by taking the derivative of the prior derivative. So, some notation that you need to know about. First derivatives, obviously we've seen different formats of notation, f prime of x, y prime of x. We've seen df dx. We've also seen dy dx. And we've also seen the derivative with respect to x of the function. So, following the same sort of idea, we have a double prime for second derivative. For a third derivative, we have a triple prime, and that carries forward on the y and the y prime of x, or double prime of x. And if we do the triple, we use 3. Anything higher than third, generally you will see the actual number. So 4 in brackets, 3, I mean you could do that if you wanted to. So something like that. So you can have those sort of notations for anything that's higher than. So n can be any number, just 4 as an example. If we talk about the other format of the notation, then we actually write it a little bit differently. We put the 2 with the d and dx squared. It's not really squared, it's a second derivative. And you can put your f there, or you can have it with your y, or if you wish to just do this. Oops, bracket. So those are the notations that we used, and the same idea would carry forward down here, that we'd have the n derivative with respect to x to the n. Here's an example of a function, a straight polynomial function, that if I was asked to find, say, the first, second, and third derivative. To find the first derivative, we would just do what we've normally done so far. We've just been using the power rule. 5 times 6 will give you 30. We drop the degree by 1. 4 by 4 is 16. Drop the degree by 1. 3 by 2 is 6. And drop the degree. There's your first derivative. If we carry this forward, we're now taking the derivative of the first derivative to find the second derivative. So we're using the first derivative and finding its derivative. Which means, again, if we use the power rule, we'll have now 150 x to the 4th plus 48 x squared plus 6. And if I need to find the third derivative, with respect to x, I am now taking the derivative of the second derivative to find it. So again, 4 times 150, so you're going to have 600. And x to the 3 plus 96x, and that would then be my third derivative. So first derivative, second derivative, third derivative. Where it gets a little bit more tricky is, of course, when you have to use the product rule or quotient rule to actually go through the first and the second derivative. So let's consider this function here, the square root of x over top of x plus 1. Now this is going to have to use your quotient rule, which we know if we have f of x over your g of x, that we take our denominator, times it by our f prime of x, subtract f of x times your g prime of x, all over your denominator squared. So in this particular case, if you wish to write out what your parts are, you have the square root of x. If you take the derivative of that, remember that this is x to the half, so then you have 1/2 x to the negative half, which is the same thing as saying 1 over 2 root x. Your g of x is going to be x plus 1. G prime of x is going to be 1. So we can use this then to find our first derivative. G of x is going to be x plus 1. The derivative is going to be 1 over 2 root x. Subtracting your f of x, which is root x times by 1, all over your denominator, which is x plus 1 all squared. You will want to simplify this down because now you have to take the derivative of this to find the second derivative. So I've just done the work for you, and I've shown that it simplifies down to this format over here. So now I'm going to use this to find the second derivative. Now again, we're looking at a quotient rule. There's my numerator, call it f of x. There's my denominator, there's g of x. My f prime of x is going to become -1. My g prime of x, well, I have to use my, well, product rule in this case. So, a little more work involved in that one. And then from there, I can then find my second derivative. So, there is the work for finding the derivative of g of x. And we also have f prime of x based on our notation of f and g for our first derivative function. Now we're going to have to also go through the same process as before and take the derivative with the quotient rule. So we take the denominator as a whole, times it by the derivative of the numerator, subtract your derivative of your denominator times by your numerator. So you can see here, this is my denominator, called my g of x. There's my f prime of x, based again on notation for what I have as my numerator and denominator in my first derivative. This is my derivative here of my g of x, again based on notation of numerator and denominator, times by my f of x, again numerator. All of this squared. It's a little messy, doesn't look so nice, but we can work through it and simplify it. So what I've done first, I've taken the -1 and I've multiplied it to move the negative out front. And then I looked at my numerator and I factored it. The main reason for this is if you actually look here, we have an x plus 1 in every single term. So by doing this, we can then factor out an x plus 1 out of everything. So we're left with -2 root x times 1, x plus 1, and then minus, in this case, 5x plus 1, negative x plus 1, all over root x, all over 4x, x plus 1 to the 3. And again, I'll go through and simplify this a little bit more for you, and then we are done that problem. So by finding a common denominator of root x, I can then have this side multiplied by root x, which then gives me just x up here at the top, and I've distributed this out, so now I have a common denominator. You can then, let's see here, -2x squared minus 2x, and then work through your whole entire numerator, so that become 5x squared minus 5x, actually make that 4x, and then minus 1. And because this is a denominator and denominator, we can actually write it as root x times by 4x, x plus 1 all cubed. Combining our like terms, we now have 3x squared minus 6x minus 1 all over root x, 4x, x plus 1 cubed. Now you can leave it like this. Another thing you can also do is you've got a root x and an x. Technically that's a degree of 1, that's a degree of a half. So you could also write it as 3x squared minus 6x minus 1 all over 4x, and because of half and 1 you have 3 over 2 x plus 1 cubed. Either or.